This is REST for back-end engineers and for front-end engineers too. In this talk, I'm going to explore the REST architectural style. I'm going to describe some of the architectural constraints that are defined by REST and ask how can they help us add and change features more effectively? How can they help us scale more effectively? And how can they help us maintain good performance? REST was invented by a dude called Roy Fielding. He's the creator of REST. He's also the co-creator of the HTTP protocol. So he's kind of the reason that we all have a job, and you can kind of say he's one of the inventors of the internet. So we like Roy. Roy wrote a dissertation in 2000 called Architectural Styles and the Design of Network-Based Software Architectures. And what he basically did was he reviewed all of the different contemporary architectural styles and ideas, chose the best bits, and then proposed REST as an architectural style for the internet. You can read his dissertation online, it's quite accessible. I'll take a wee sidebar just to talk quickly about constraints. So in software engineering, we choose to apply constraints to ourselves. Some examples of this might be the single responsibility principle, or DRY. And basically what we're doing is we're telling ourselves, even though you can do things this way, and it might be more expedient to do it that way, there's a benefit to not doing it. And so we constrain ourselves. And REST is exactly the same. REST basically suggests 6 constraints that we apply to our API design. And these constraints are separation of client and server, statelessness, cacheability, uniform interface, which has 4 subsections, layered system, and code on demand. Now, I'm only going to talk about 4 of these today. Separation of client and server, cacheability, and then within the uniform interface, I'm going to talk about resources and something called Hatios. REST claims that the benefits of applying these constraints are performance and network efficiency, scalability, modifiability or evolvability, simplicity of interface, visibility of communications between components, portability of components, and reliability in resistance to failure. I'm only going to focus on the first 3. I'm going to focus on performance, scalability, and I think most importantly for Clio, I'm going to focus on evolvability, the ability to continue to make changes as we develop. So the first constraint that I want to talk about then is the separation of client and server. The client and the server should be as loosely coupled as possible. The client and the server should be able to speak to each other without knowing anything about how the other one works. And I'm going to show you some examples of maybe like common patterns you might see in code where we violate this, just to help you understand what this constraint actually looks like. So the first one shouldn't be too controversial. I'll give you an opportunity to read the code there. Here we have a JavaScript function, and we are just calling a list of books from the server. But the client is also specifying that the books should be in order of the created at column on the books table. So this is a blatant violation of the client-server separation constraint, because not only does the client know that there's a books table on the server side, it also knows that there's a created at column. That means that the client is effectively dependent on those always being there. The server can't change the table name or change that column without breaking the client. It's really, really brittle. A second example, this is a little bit more involved. I'll give you a chance to read the code. So what's happening here is that we are fetching the details of an author based on the ID of a book. So we're first making a fetch request, a get request to fetch the book's representation, the data of the book, and then we're plucking author ID, a property from that book, and then we're using the author ID to make a second request to the user's endpoint to pull out a user. Now, I argue that this is a violation of the client-server constraint because the client is making assumptions about how the server defines an author and a user. Are those necessarily the same thing? Will they always be the same thing? So this is the client sort of pushing its luck and making assumptions about how the server should always work. This last example is going to be a bit more controversial. I hope you'll bear with me to the end of the talk, and I'll try and clarify. But here we have a function where the client is fetching a list of books from the server. And along with the request, the client is providing a page parameter and a per page parameter to tell the server how to paginate these results. Now, this is very, very common practice, but I argue that it's not strictly RESTful because the client is assuming that the server will recognize parameters called page and per page, and it will use them to paginate the results. That might be true now, but it might not be true in future, and things might change. So there is a more RESTful way of approaching this, and I'll show you that later. Some back-end examples now. So I'll let you read this response. This is basically the server's response, a representation of a book object. And here, what we have is a property on line 4 called page header. This is the title of the book, but the server is telling the client, you should use this as the header on the page. That's the server making too many assumptions about how the client is going to use this data. Similarly, you've got line 5, the font size. The client server has no right to tell the client how it should be presenting data. That's completely concern of the client. And then finally, on line 9, we have this display image property where we're providing an image name. There's absolutely no context as to how the client could find that image. Is it something that's on the client side? Is it on the server side? Is it on a third-party CDN? There's no further information. So this is basically the server assuming responsibility on how the client should render this data, and also assuming that the client knows what to do with it all. So this is another violation of the client-server constraint. And again, structuring things like this is just going to make it difficult to change things in future. You know, if the client decides that it's not going to have a page header, or if the client decides to use different font sizes or to use images in a different way, then this response is no longer valid for the client. We've broken something. And that often means that we then end up having to support multiple legacy versions to keep multiple older versions of a client functioning. Last example. Again, this is quite common, but I argue that it's not RESTful. So here we have the server's representation of a book resource. The problem here is that nested within this book resource is also the author. And it's an array of the book's comments and an array of the book's reviews. Now, to me, this screams out that this representation was designed for a particular view on the client side. That means that this representation is too specialized. If we were to, it's not general. We want it to be general. If we were to try and use this at another point within the client, then we might end up that we're pulling comments and reviews down, even when the client doesn't need them for any other context. And again, if we make changes to how that client view looks, or if we want to make changes to the server, we'll end up having to maintain legacy code for a long time, or something breaks. So just to summarize all of that then, REST promotes strongly decoupling the client from the server as much as practically possible. Doing so allows both components to evolve independently, and it makes making changes easier and cheaper, and also reduces the risk of us having to support legacy implementations. Second constraint. So the second constraint I want to talk about is caching. REST suggests that we should make things cacheable. Just a quick sidebar on caching. I consider caching to be an optimization. It's not necessarily something that you want to do right away. Caching is hard, or can be hard, but it is probably something you'll want to do eventually. So we want to allow ourselves the opportunity to be able to cache in future, even if we're not doing it just now. If you consider the previous example that I showed you of the book with the nested resources inside it, it's quite likely that the title of the book and its ISBN and all of the other properties of the book itself are never actually going to change. And that would lend itself to being cached publicly, basically indefinitely. The author, similar author's details probably aren't going to change very often. Whereas the comments and the reviews on a busy site like Amazon or something like that, these could change every minute or every hour. So in carrying these along with the book representation, it makes it very difficult to effectively cache the book. If we do cache it, we're only going to be caching it for minutes at a time, rather than the forever that we basically could do if we were to just show the book. So the REST solution to this problem would be to reference these related resources within the body of the book, but reference where they are rather than their content itself. REST calls this concept hypertext, and it's something I'll go into a lot more depth later. But if you look at the body of this, if we were to consider this a representation of our book, this basically would never need to change and could be cached indefinitely. This is already a fairly common pattern in the internet now. The JSON API standard supports this concept of a link object. So hopefully it's not a completely new idea, but it's definitely something that I think one could lean into if you really wanted to embrace REST. So some of you might be asking from that previous example, won't this mean we're making a lot more requests? The answer is yes, and I think that's okay. So when I go to meetcleo.com, when the page first loads, it pulls down about 76 separate resources from 26 different domains. When I refresh the page again and reload it, about 55 of those resources are loaded from the local cache. Only about 21 of them are actually fetched from an external server again. So the web already implements this concept really well. It's totally normal for a website to make dozens, if not hundreds, of requests for resources and then to cache quite a lot of them. For some reason, we just don't consider it to be applicable to JSON API. But Fielding says, an interesting observation is that the most efficient network request is one that doesn't use the network. And I think that's really something that he thought was the way to build the internet efficiently, was to have caching done at multiple points across the network, so that often the server itself isn't even having to serve the request. So let someone else do it. One of the ways that you can do this effectively is basically to separate content into public and private content. If we think about the representation of our book, for example, there's nothing in there that's really sensitive. It doesn't have any user data, it doesn't have any bank details or anything like that. So in theory, we could just say that the cache headers for this book are public, and let that be cached at the CDN level, at the internet service provider level, or even at the local client level. And we're quite happy to do that. If it's private content, if it's something that we consider to be sensitive data or proprietary data, anything like that, this can actually still be cached at the client level quite efficiently. And doing this well could save theoretically millions and millions of requests a day for a high traffic system. Clio has the goal of being a bank of 1 billion people one day. We're really going to have to lean into caching at some point if we're going to be serving that level of customer base. And this is absolutely Fielding. If you remember, he's the creator of REST and co-creator of HTTP. This is his vision of how the internet should work. It should be a distributed network where resources are all served in the most efficient way possible for that resource. So to summarize this section then, REST wants us to consider making our resources cacheable. Caching is an optimization. We don't want to optimize too early, but we will probably want to do it one day. And so we want to avoid making decisions now that could make caching difficult in future. Third constraint I want to talk about then is just this idea of resources. The central concept in REST is that we are defining resources and then we're performing actions on these resources. Rails incorporates this concept so well that we kind of take it for granted, but we sometimes mess it up anyway. And I think it's because people are not formally taught about what resources actually mean. So I'm going to give an example of that, and hopefully it's one that we can avoid. So a few years ago, the Rails community just invented this idea of 7 RESTful actions. That's index, show, new, edit, update, create, and destroy. And people started to think of this as, if you're trying to do something that isn't one of these 7 things, then you should define a new resource. In our example of a book, we might want to archive a book. An archive is not one of these 7 things. And so what people started to do was to create what I call meta resources. Just to show you, this idea of 7 RESTful actions is prolific, and people all started saying it at once for some reason. I think it's nonsense. There's nothing in REST that talks about 7 actions. That's kind of like saying that there are only 7 Ruby object methods. But what people would actually start to do then is that they would define a resource for an action that they wanted to perform on another resource. And I call this a meta resource. Here then, to archive a book, they would create something called a book archivals that's managed by the book archivals controller. And you would post to book archivals in order to archive a book. I'm bringing this up because I think it shows a misunderstanding of the concept of what a resource is in REST. A resource is something that is identifiable and can be acted upon. You can take an action on it. And so to me, this is just a refactoring, but it's not REST because there's no resource being created for a book archival. You know, you can't share a URL to say, have a look at this single book archival over here. So I think, you know, a typical way of doing this in a RESTful way would just be to add another action as a member in the roots, and then define the action in the controller. I am not unsympathetic, sorry, this is the RESTful way to do it. I'm not unsympathetic to the fact, though, that we often want to refactor controllers to be simpler. And so I think it's completely valid to extract an action into a separate controller. All we have to do, though, is still within our roots, define this action on our books resource. We're just pointing it to a different controller and a different action. This is RESTful, and I think it's also a good refactoring. The important point that I want to stress here, though, is that our server's REST interface, which is effectively our roots, should not be coupled to the implementation at the application controller level or at the domain model layer level. Actions are performed on resources and it has nothing to do with how we express it in the controllers or in the models. So just to summarize that then, REST focuses on performing actions on resources. Actions are not constrained to just CRUD, and our REST interface should be completely decoupled from the application controller layer and the domain model layer. And refactoring our code then should not affect our REST interface. There's one more constraint that I want to talk about. This one's quite controversial, so I've marked it as 3 chilies hot, and it's called HATIOS. So what is HATIOS? Well, HATIOS is an acronym, stands for hypertext as the engine of application state. In terms of pronunciation, I always just think adios. That's my own personal mnemonic. You're free to choose your own. But what does that actually mean? Well, it means that the representation of a resource, in our case, we've got a JSON API, so it's the JSON body. It should include cues for the client as to what actions are available. This allows the client to discover at runtime what they may do. And it allows the servers to change those things without breaking the clients. Now, I'm going to explain it in a bit more depth. This might seem like a weird concept for a JSON API, but I want you to understand that this is just how a web browser works. This is completely normal for the internet. But REST says you should do it for other media types too, not just for HTML. So if we go back to that previous example, the pagination one, I claim that having the page and per page parameters be known to the client was technically a violation of this client-server coupling constraint, because it meant that if anything was to change in future, then we could end up breaking something. More RESTful approach, applying HATIOS, would be to include in the response body itself a URL, a reference to where the next and previous pages are. And this URL that sort of dictates a future action, this is basically known as hypertext. It sounds like a really archaic way of speaking about the internet now, but this is hypertext, and it's basically just a URL embedded in a document that allows us to do the next thing. Why this is beneficial is because if we choose to change how the server structures things like pagination, in this case, we've just changed the URL pattern, but what if we were to move away from offset pagination over to cursor pagination? Well, If we're just telling the client, go here for the next page, rather than saying, here is what you must do to find the next page, then we don't break anything by making that change. I've actually worked on projects where we did make this transition from offset pagination to cursor pagination, and it was a nightmare because we ended up having to support both because we're supporting legacy versions of the application that we're still expecting to use offset pagination while also serving cursor pagination. That could have been completely avoided if we had applied this HATIOS principle. So the benefits of HATIOS then are that we can change the server without breaking the client. We don't have to support legacy code. The server then also becomes self-documenting for the client. So all you have to do is pull down the body and look at all of the different options that are available. You don't have to go running for the latest version of the API docs. And it also means that we can control features at a more granular level. So if we wanted to make something available to this client, but not this client, we can actually do that by the directives that we include in the response body. Here's another HATIOS example. So again, we're going with the idea of a book. And suppose we want to allow some users to archive a particular book. Well, we can just include there a link to the archive action and also a note to say that this should be sent with a post request. And that tells the client that they may archive this book. Now, it might be that we only include this to admin users and we don't include it to regular users. Basically, the client just has to check for the existence of that link, and that link will tell them what actions they may take and what actions they may not take. So the server is telling the client in real time what actions may be performed on a given resource and how to do it. And remember, although this sounds weird from a JSON API perspective, this is just how browsing the web works. You load a web page and there'll be links as to what you can and cannot do. And those links can change based on authentication or new versions of the code being pushed out or any number of things. So by applying this, we can actually change the available actions or the URLs that those actions take place at, or the verbs that we use to process those actions. We can change them all at runtime and we don't break the client. I've mentioned before, we can control this then by things like feature flags. We can control them by user permissions, and the code becomes self-documenting. So we don't have to send further documentation to the client in order to understand what to do. This idea is fundamental to doing REST properly. Fielding has been emphasizing this for quite a while. He's got a blog post here just saying REST APIs must be hypertext driven because this HATIOS principle seems to be the part that most people are reluctant to adopt within REST. And so in Fielding's own words, if the application state is not being driven by hypertext, then it cannot be RESTful and it cannot be a REST API, period. Oh, sorry, I've jumped too far. To summarize that section then, REST wants the server to tell the client about the actions that are available to it in real time. This might include listing the available actions for a resource in the response body so that the features can be controlled more easily, for example. This should allow us to change the server without breaking the client, and it should mean that we spend less effort supporting legacy versions. So to summarize all of that then, REST provides constraints for API designers to apply when designing their application interface. These constraints, if applied properly, should optimize for scalability, performance, and I think most importantly to us, evolvability. If we aim to strictly decouple the front-end client from the back-end server as much as practically possible, if we present resources as representations that can be generally useful and not structured for specialized use cases, if we cache, or at least don't build our API in a way that makes future caching impractical, and if we focus on resource representations guiding the client on what may be done now, rather than assuming that A, the client already knows it, and B, that these options will always be supported. I've got some links to recommended reading. That's the end of my talk. I'm a massive nerd on this topic, so if anybody wants to have a private chat with me afterwards on any of the points, I would welcome it. Otherwise, I'll open up to any questions.